1. Okay. Oh, it's recording. Okay, so let's get started, guys. So this is the review for exam 2. It is on sections 8.1 through 8.9. So not on all of chapter 8, but on most of it. Okay. If you recall, as we, or as I said in class, there were 6 different types of questions really that we've encountered, right? Confidence interval, hypothesis testing for a single sample, a single population, confidence interval or hypothesis testing for paired samples, right? When you have 2 of them, but they're paired, and then confidence interval and hypothesis testing for 2 independent samples. So those are the 6 different types of questions we can encounter, and we actually have 1 of each within this review. They are in no particular order though, so part of what we're going to do in this review is practice identifying which one it is. I am going to be utilizing this formula sheet as well as we're going through them, okay? So feel free to have that handy. Also, oops, I don't mean to do that. Also, in case you're trying to compare the answers on here to the previous original review, although they're extremely similar, there are some small minor changes I made to a few of them. So if you're like, oh, like this doesn't match up the answer key to the other one, well, it's probably because I made a small little change, okay? So really you want to, if you're looking at this, you want to use this as the answer key. Okay, so number 1. The following data represents a random sample of the average price of textbooks sold at several community colleges' bookstores. Construct and interpret a 99% confidence interval for the population mean price of textbooks sold. All right, so first thing, let's identify, I'll keep reading here, where on this flow chart we are going, okay? So obviously we're starting here with the mean average, but tell me, for this problem, again, look at it again, are we dealing with 1 sample, 2 paired samples, or 2 independent samples? 1 sample, good. So that means from this flow chart, we go right up here. So now you need to figure out, is this asking for a confidence interval, or is this asking for a hypothesis test? So look back here, what was this asking for? Confidence interval. It even says right here, construct and interpret a 99% confidence interval. So that means we're using this guy up here. So I'm going to go ahead and mark it. You don't have to if you don't want to. But for this example in particular from this review, question 1, we're doing confidence interval for 1 sample. That leads us right there. And so that shows us what formulas we're going to be utilizing and what information we need. Okay? So back to the question. Part A, what is the mean price of textbooks? Well, I should have a calculator on here.
Where are we rounding?
I know, it doesn't say. Let's go to 3 decimal places.
I just figure she'll figure it out, know what we're doing.
Yeah, I'm just kind of winging it on that part. So can I do both at the same time? Can I have?
Click the 3 buttons on top. You should be able to go into the split screen. So
Say it again?
If you go back to where it says good notes, there's 3 buttons on the top center.
And
The
then
3 dots
these
at
ones?
the top of your screen. Top, middle.
Oh, these ones.
Yes. And you can
Split
do split view.
view. Oh my god.
And then just click on whatever app you're using.
Oh my god.
There's a little slide in between it. You can adjust it.
Thank you. I wonder if it'll let me. There we go. Perfect. Thank you so much.
That's ridiculous.
I'm so happy right now. Okay. So I need to enter in all of this data. So we're going to stat, edit. I need to clear out the old stuff. Stat, edit. Let's see if it'll let me clear all the old stuff. Clear. It's not as good as a normal calculator. I have to actually delete it. Okay, so we're entering all this data. So 65, 40, 74, 16, 56, 36, 42, and 110. Wow. Okay. So enter in all of your data. Once you've entered in all your data, we go back to stat, calc, 1 variable stats, and we're doing it from our list 1. And here is all the information we need. So remember, the mean price of textbooks is on our calculator, that's our X bar, right? Our X bar is our mean price of textbooks. Let's round to 3 decimal places. So X bar equals, our mean is 54.875.
We shouldn't use 2 decimals since we're talking about money, or no?
I just,
Okay.
yeah. Yeah, 2 decimals would also make sense, but
Okay.
since I didn't state, let's just do 3,
Okay,
because why
fine.
not? It's all right. That's a good question. That actually would make more sense. Part B, what is the standard deviation from the sample? That is also from our calculator. So on our calculator, what should I look at?
SX.
The SX, good. SX is the standard deviation. When you write it out, though, you just do S. You don't have to write SX. And that is 28.693. I'm still just going to 3 decimal places. All right. So the mean and standard deviation are just from our calculators, yeah?
Yes.
Okay. Part C, what are the degrees of freedom? Okay, well, we know you can even go back to your formula sheet if you need to, in case you forgot. So we're working with our confidence interval up here on top. And if you look off to the side, it has a little reminder here for you. Degrees of freedom, DF, is equal to n minus 1. So in case you forgot, don't panic. It is on the formula sheet. So the degrees of freedom, which is equal to n minus 1, where n is our sample size. How many data values do we have in our sample size?
8.
8. So it'll be 8 minus 1. You could count them. There's 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 1 is 7. All right. Next, what is the critical value? We denote that with a T sub C. And remember, our critical values come from here, from this table, right? This is our critical value, where we need to know the degrees of freedom and you need to know the confidence level. So we just said the degrees of freedom was 7. Oh, question?
Do we need to put the TC equals and then the answer? Can we just write the answer?
I would like to see the T sub C. Yeah. Good question. So our degrees of freedom is 7, and the confidence level is 99%. So see where those 2 values intersect. So here's the degrees of freedom is 7, confidence 99%. Where does that meet?
3.49.
Yeah, good, right here, 3.499. So 3.499. Yes.
Since the margin of error formula isn't on the formula sheet, could I write that?
It is. It is on the formula sheet. So let's take a look. So good question. So part E, find the margin of error for the confidence interval. So going back to our formula sheet, that is this guy right here. E equals, that is our margin of error. So E equals T sub C of S divided by the square root of N. That is our margin of error.
Can I write that E equals margin of error?
Yes, I am okay with that. If off to the side, like right here, you want to write margin of error, I am okay with that. Yes.
Let's say I wanted to use this cool calculator function in there
Mm-hmm.
and just write out my my lower and my upper, my confidence interval. Can I do that using this?
If the exam specifically asks you to find the margin of error separately, you still need to find the margin of error.
Okay.
Separately.
With the formula.
Correct. Yes.
I can't just write my T interval.
Correct. I mean, like, so if your calculator, you figured out how to do that on here and you went straight to here, then you would miss out on these points. So you'd still need to do this.
Okay.
But thank you for asking. All right. So the margin of error is equal to, I already forgot what it was, T sub C times S divided by square root of N. So T sub C times S divided by the square root of N. And at this point, you know each piece of information here. So it's a matter of substituting in. T sub C, we said, was 3.499 times S, we said, was 28.693 divided by the square root of N, where N was 8. 8 was the sample size. plug this into my calculator. If it'll let me. Oh, there it is. Okay, there we go. So 3.499 times, ooh, I wonder if this has the function, oh, fraction, it does. Okay, cool. 28.693 over the square root of second root of 8. And we get the following. We get 34.496.
35.
Oh, 35, thank you. Misread that. 35.496. All right. Any questions there? Okay, next you can find the confidence interval. And again, in case you panic, in case you're freaking out, you're like, what's the confidence interval? It's right here. It's given to you right here. The lower bound is x bar, or the mean, minus e, comma, x bar plus e. So it's restated here for you in case you need it as a reference. So it is x bar minus e, comma, x bar plus e. We know both of those values, so substitute them in. X bar, we said, was 54.875 minus 35.496, comma, 54.875 plus 35.496. And that equals, and you just enter them separately into your calculators. So 54.875 minus 35.496. That is, the lower bound is 19.379. And then repeat for the upper bound, but this time you add. So 54.875 plus 35.496. And that'll be 90.371.
In interval notation as well, correct?
This
Okay.
is interval notation, yes.
Okay. Oh, because I wasn't looking at what you were doing.
Yeah, so interval notation just means that you have it within the parentheses. So you have your lower bound through your upper
Yeah,
bound.
when you use the calculator function, it gives you 19.375 and
And
90.375.
That just has to do with the rounding. Since we rounded here to 3 decimal places, your calculator probably went further. They probably went to as far as it could go, because your calculator is able to store that memory.
So,
Wait, so if it was 34.90, would that be correct, or?
Right here?
Yeah.
Well, assuming that you did 3 decimals here, like how I did, it should be 0.496.
Okay.
Yeah, and then again on the exam, I know I didn't say here where to round, but on the exam it should say where to round. And in case there is any confusion or questions, in case I missed something and I didn't say where to round, just don't hesitate to ask. Yeah. All right, part G, interpret the confidence interval. Okay, so we are 99% confident, because that's what we started with, that the mean price of textbooks sold at the bookstore is between, and now since we're really talking about money, I'll go ahead and put it to 2 decimal places, is between $19.38 and $90.37. Any questions on any part of number 1? So again, overall, this was an example. I'll go back here. This was an example where it was 1 sample, confidence interval. Okay, so remember, you want to be comfortable being able to identify it. That might be a question on the exam, being able to properly identify what type of problem it was. And feel free to use this flowchart to help you. Like, okay, was it 1 sample? Was it a pair sample? And then which direction? So this was 1 sample confidence interval.
So in the text, is it gonna like right away say if it's like one sample or the pair samples, or we have to actually look?
It would be something like this, because notice within here it didn't say one sample, right? We had to decipher that ourselves. So it will not say whether it's a paired sample or two independent samples. It won't say that. That's something you have to determine yourself.
Okay.
All right, you guys ready for number 2? Okay, and stop me if you have a question, or let me know if I'm going too fast, or if you have any questions. Okay, number 2. A random sample of 20 schools in 2017 had a mean number of student awards of 50 and a standard deviation of 25. In 2018, a random sample of 25 schools had a mean number student awards of 70 and a standard deviation of 35. Assume the number of student awards is normally distributed. Test the claim that the number of student awards increased between 2017 and 2018. Use a significance level of 0.05 or 5%, and degrees of freedom is 43. Okay, so first off, before we do anything, let's come back here and determine which way we're going. Okay, was this one sample? Is it 2 paired samples, or is it 2 independent samples? Yeah, correct. Very good. It's 2 independent samples, right? The number of awards from 2017 has no impact, no influence on the awards of 2018, so they are independent. Good. So we're here. Now ask yourself, did it explicitly ask for a confidence interval, or rather are we doing a hypothesis test? Hypothesis test, because it's asking us to test the claim. Test the claim is hypothesis test. Okay, since it says to test a claim, that's a hypothesis test. So again, you don't have to write this on your notes. You don't want to, but this is, I'm just making note for ourselves. This is what we're using for number 2. Overall, here's the formulas we want to be using, and here's some additional notes with regards to it. Okay? Everyone okay there? Mm-hmm. Okay. So first of all, what is the null and alternative hypotheses? So recall, null we represent as H sub naught. Okay. And whenever we are working with 2 independent samples, the null automatically is mu1 equals mu2. Always. Okay, always. 2 independent samples automatically start off with mu1 equals mu2. That's our baseline, saying that, hey, the mean of the awards given in 2017 and 2018 are equal. Okay, that's our baseline, just assuming they're equal. Then the alternative is going to depend upon the question itself, the testing the claim. So this says, test the claim that the number of student awards increased between 2017 and 2018. Be careful, be careful. So I'm just gonna make a little note here. I just like to keep it in order, so I'm assuming that mu1 is 2017, mu2 is 2018, right? Just keeping it in order. So with that order, mu1 is representing 2017 and mu2 is representing 2018. If we were to say that it increased between 2017 and 2018, and I need to write it as an inequality format, is this saying that mu1 is less than mu2 or mu1 is greater than mu2? Less than, right? Mu1 is less than mu2 because we're saying that it increased from 2017 to 2018. That means we're claiming that 2018 was more. We're claiming that 2018 was greater. So that's our null and our alternative. It didn't ask for it, but what tail is this?
Right. Oh.
Left tail. Question?
So like other questions would say like, oh, use the mean, right? So like for the alternative, like use the mean as mu1 and mu2.
mu1.
Have that in
The mean is x, the x bar.
No, but like I think we did one in class where it says like let mu1 be the mean of this, and then I don't know if you.
I don't remember. I'm sorry.
That's why I have to like write it all out like in columns. Like I have to do 20.
Yeah, which we're going to do. We're gonna do that down here. Yeah.
You know what I mean?
Yeah.
Because,
Okay. So part B, are the normality criteria met?
Yes.
Yes, why?
It states one distributed.
Yeah, it says right here, assume the number of student awards is normally distributed. Right? Done.
And it has to say random too, or?
No, I'm just looking for the normally distributed.
Okay.
I mean, because sometimes in the book they include that, sometimes they didn't, but what was always consistent was this, the normally distributed. If it did not say normally distributed, then what would you look for?
Greater than
Greater than
That the sample sizes were greater than 30. It has to be one of those two at least. So yes, and I'm just going to quote it. Assume the number of student awards is normally distributed. Okay. Part C, list the sample statistics. And when it says list the sample statistics, it's basically just saying organize your information. Okay, so for group 1, we said that was going to be 2017, right? So we have X1 bar, S1, and N1. So we're just organizing our information here. So what was, I'm just going to highlight it first of all. In 2017, it was a sample of 20 schools. It had a mean number of 50 and a standard deviation of 25, right? All that information is provided to you. We're just pulling it out. So the mean, we're told, was 50. The standard deviation, we're told, was 25. And then the sample size, we're told, was 20. Yeah, so just organizing that info. And then do it again for our second group, which we said was 2018, right? So we're going to call that X sub 2 bar, S2, and N2. But again, this information is given to us. It's just a matter of identifying and pulling it out. So for 2018, there's a sample of 25 schools, a mean number of 70 awards, and standard deviation of 35. Okay, so it's all there. Pulling that out, the mean was 70. The standard deviation was 35. And the sample size was 25. Any questions there? Okay, part D. Compute the difference of sample means. What does difference mean? Subtract. And of all of our info here, which ones are the sample means?
X bar.
The X bar, right? X bar is the mean. X bar is the sample mean. So it's just telling you to take these two data values and subtract them. So subtract X1 bar minus X2 bar. So that'll be 50 minus 70. And that gives us negative 20. Any questions on part D? Okay, part E. Calculate the test statistic. Well, you're definitely not expected to memorize that formula. Go back to here, and we said for question number 2, we're using this guy. This is the formula for our test statistic. T equals all of this stuff. All right, that's our test statistic. It's given in the formula. So let's bring that on over. So the test statistic equals X1 bar minus X2 bar over the square root of S1 squared over N1 plus S2 squared over N2. From here, it's a matter of substitution, right? For the numerator, the X1 bar minus X2 bar, we already did that. Didn't we just do that in part D? So just plug that in. That's negative 20. All right, our X1 bar minus X2 bar we just did here. We said that was negative 20. Excuse me. Over the square root of the denominator, we can substitute in our values. We have these values, S1, N1, S2, N2. We had already listed that over here, right? So it's just a matter of substituting it in. S1 we said was 25. So 25 squared over N1 we said was 20. Plus S2 squared, so that's 35 squared, over N2, which is 25. Now, at this point, it's kind of up to you, your level of comfort, and also kind of like how good your calculator is as to how you want to do this. I personally am going to just move the numerator over, and I'm going to do the denominator on its own. So I'm going to do that over here. Oops. So the square root of, whoa, that's an add. How do I get the add to go away? There it goes. Okay, so the square root of 25 squared over 20 plus, have another fraction, 35 squared over 25. And that I'm going to go to 3 decimal places, 8.958. Plug this into my calculator. Actually, I'll just do it as is. Negative 20 divided by 8.958. I get negative 2.233. Yes.
Alpha is p-value, right? The little a thing.
This guy up here, this guy,
Yeah.
that's our significance level. Alpha is a significance level. Mm-hmm.
Professor,
Yes.
my calculator, it was supposedly loading and everything, I don't know. And then this
What'd you
weird,
guys get?
2.23.
Negative?
I don't know.
It just restarted.
Oh,
There
okay,
you go.
thank you.
I got 2, 3, 2. 1, 2, 3, 3. We're doing 2 or 3?
3 decimal places. Any other questions up to here? All right, part F, let's find the p-value. So we know we're going to use our calculators for that. P-value equals TCDF. Since this is a left tail test, it's going towards negative infinity, right? So that'll be negative 99999 up to the test statistic, which is negative 2.233. And then does anyone remember what's the last thing we need to include?
Degrees of freedom.
Degrees of freedom, which we were told what the degrees of freedom are. We're told in this case, it's not always given, but in this case it is. It's given to be 43. The degrees of freedom was given to be 43. And again, look here if you need to. Here's a reminder of the TCDF, what's needed, the lower bound, the upper bound, and degrees of freedom. Yes.
Even if it didn't say if it was left-tailed, just because the test statistic is negative, wouldn't we still start with negative 999?
Yes, excellent. That's a really good thing I want to elaborate upon further with you guys real quick. So it's kind of a side question, but it's good practice for the exam and overall understanding. Anytime the test statistic is negative, such as it was in this example, anytime the test statistic is negative, we can be more than fairly certain, not 100% guaranteed, but more than likely, you can expect it to be a left-tailed test, correct? Mm-hmm. If our test statistic was positive, more than likely it's going to be what?
right?
A right-tailed test. Okay, good.
So, like-
Sorry, she had a question for you.
What's this up here? What are we using this for?
Oh, that's a significance level. So remember, alpha is just another way of writing the significance level is, and 0.05 is 5%.
Can I write that on my?
Yes. You had a question?
Yeah, so like the negative 999, it's always gonna go first
When it's a left-tailed.
when it's left out?
Mhm.
Okay.
Yeah. If it were positive, then that positive 999 goes second, right? Because you always do smaller to larger. All right, so
Calculator's doing something really weird.
yours is?
Yeah.
Okay, 1 second. So TCDF, let me try it myself. And I haven't done it on this little fake calculator before, so let's see how it works. Makes me a little bit nervous. I haven't used it. Where's the comma? Comma 43. So you should have gotten, let's go to 3 decimal places. Oops, wrong color. 0.015. Okay, 0.015. Oh, okay, so go down. Hit, go ahead, enter. Okay, so then do, or yeah, hit enter, so it gives the answer.
How about
Oh. This isn't 70, that's 35. Okay. You're welcome. Okay. All right, so now that we have our, bless you, our p-value, we can go on to part G and H, or we're starting to come up with some conclusions here. So part G says, what can you conclude about the null and alternative hypotheses? Well, the p-value is 1.5%, which is less than or equal to our level significance, 5%. So remember, this 5% is coming from here, right? That alpha equals 0.05 is saying that the significance level is 5%. So tell me, this is or is not statistically significant?
Is.
It is. So it is statistically significant. Do we reject the null or do we not reject the null?
Reject.
Good. Reject the null. And do we support or do we not support the alternative?
Support.
We support the alternative. Hypotheses. All right, so since the p-value is less than or equal to our level of significance, we say it's statistically significant, which means automatically we reject the null and support the alternative. And then lastly, we state a conclusion in the context of the problem. So at the 5% significance level, the sample data support or not support the claim?
Support.
Support. Good. The sample data support the claim that the mean number of student awards increased between 2017 and 2018. And remember, I'm really just pulling that claim from right here. Test the claim that the number of student awards increased between 2017 and 2018. So I put right here, support the claim that the mean number of student awards increased between 2017 and 2018. Any questions? Okay, we're doing pretty good on time. Let's keep going. Number 3. Okay. A sample of students receiving financial aid was conducted on the time it took to process their application. The table below lists a random sample of application completion times in days. Assuming financial aid completion times are normally distributed, use the significance level of 0.05 or 5% to test whether the population mean response time is less than 60 days. All right, before we move any forward, let's take a look at our flowchart, okay? So, tell me, was this one sample, paired samples, or 2 independent samples? It's one sample, because if we look here, it's just one sample, right? We're only working with one sample of data of students.
That's why.
Okay, so yeah, so it's one sample. We took a sample of 14 students and got their days, okay? If instead it had been like, oh, we're going to do this sample in 2020 and then let's test it again in 2023, right? That would be two samples, okay? We only have one sample here, so we know we're up to here. Next, was this question asking about a confidence interval or is it hypothesis testing? Hypothesis testing, because it says test whether the population mean response time is less than 60 days. We're testing it. It's a hypothesis test. Okay, it's a hypothesis test. So this is what we're going to be utilizing. Oops, wrong color. For this question. Okay, we're going to be utilizing these formulas, and if needed, here's some additional information that could be helpful. Okay, so we're using all this for the hypothesis testing. Okay, so part A, what is the null and alternative hypotheses? So, let's say again?
Mu is 60.
Yes, mu equals 60, right? You always have to have just a starting point. And then this problem, we're comparing it to 60 days. And the null hypothesis always has to be an equal sign. So just start off with the baseline of the mu, the population mean, equals 60 days. The alternative comes from the claim. And the claim is that the population mean response time is less than 60 days. So how do we write that?
Mu is less than 60.
Mu is less than 60, right? That's our claim that we're testing, that it's less than 60 days. It's not asking for it, but is this a left-tailed, right-tailed, two-tailed? Left-tailed, because it's less than, so it's going to the left. Yes?
Question, when it says, sometimes it's equal to 0, when would that be?
That we're going to see with paired differences. Yeah, more than likely that occurs with the paired differences. Part B, are the normality criteria met? Yes, why?
Normally distributed.
Yeah, it says it right here. Completion times are normally distributed, right? If it didn't say that, then you would check to see if the sample was larger than 30. So, yes. And it's because assuming financial aid is completion times, financial aid completion times are normally distributed. Part C, list the sample statistics. And remember, the sample statistics is your mean, sample standard deviation, your n, right? Do I have to do it 2 times, like how we did here with 2 groups, or just is it just one set of list? Just one set, because we're not working with 2 different groups. This is a single sample, right? That's what we said here. It's a single sample, one sample, hypothesis test. Okay, so where's my pen? So what I want you to find is X bar, S, and N. So let's start with N. Remember, N is the sample size. How many data values do we have in our sample? 14. So we could do that. How am I going to find my X bar, my mean? How am I going to find my mean and S, the standard deviation? Yeah, you got to do it in the calculator, right? We're going to do this in the calculator. So do stat, edit. I need to delete all this old stuff and input the new data. So take your time inputting that.
Are we rounding to 3 decimals still?
Yeah. Let's do 3.
Yeah, I am.
Let's do 3 decimals still.
The degrees of freedom are 3s too, so.
42. Okay. Once you've entered in all of your data, you go back to stat, calc, 1var stats. Make sure it's list 1, which it is, and here is all the info. All right, so our X bar is, or our mean, is 59.714. And S, the standard deviation, is 13.106. Any questions there? Okay, part D, calculate the test statistic. And again, in case you forget, we know to use this formula. This is the formula we use to calculate the test statistic. T equals all of this stuff here. So I'm going to copy that over. So T equals X bar minus mu divided by S divided by the square root of N, which we have each piece of information here. So it's a matter of substituting it in correctly. The mean we said was 59.714 minus mu. Mu you said up here. That comes from your null hypothesis. You said that mu equaled 60. So minus 60 over S was 13.106 divided by the square root of N. So that's divided by the square root of 14. I'm going to plug this into my calculator. Luckily, I gotta do a fraction. So fraction 59.714 minus 60 over, and then you have another fraction. Be careful if you're, another add. Oh, it's the Kardashians. Let's see if, there it goes. Okay. They look so happy. Remember, if you're doing this in a calculator that does not have the fraction option, to be careful with your parentheses, or maybe you have to do it in several steps instead of one step. So just be careful when doing so. Square root of 14. And we get the following. I'm going to round this to 3 decimals. That is negative 0.082. Okay. Any questions there? So next we can find the p-value. So the p-value equals TCDF. Tell me, do I start with the negative infinity or do I start with my test statistic? Negative infinity, good, because of the left tail. So negative 9999. The upper bound is the test statistic, which is 0.082. And then what comes next is the degrees of freedom. We were not told what the degrees of freedom were, but look back to here if needed. And here's a little helpful hint, right? The degrees of freedom for this case, hypothesis test here, degrees of freedom is n minus 1. Where what did we say n was?
14.
We said it was 14. 14 minus 1 is?
13.
13. So the degrees of freedom is 13. Because of n minus 1. 14 minus 1 is 13. All right, so do this in our calculators. TCDF. Lower bound is negative infinity. Upper bound is negative 0.082. And remember, my calculator did this automatically because it's this weird calculator. But on yours, you just do negative like 99999, right? Comma 13. And let's round to 3 decimal places. That is 0.468.
I have a question. So, for example, let's say the degrees of freedom are given, for example, let's say 17. So I don't subtract, do I just leave it alone?
Correct. If the degrees of freedom are given, then that is the degrees of freedom.
Okay.
Degrees of freedom is 17, then it is 17.
Because I always subtract.
Yeah, but yeah, so when you're subtracting though, notice when you need to do that subtraction, it's that the degrees of freedom equals, that means you need to solve for it. It wasn't given. And in that case, it's n minus 1, where n is the sample size. Okay?
Oh, thanks.
And also take note, guys, the only times the degrees of freedom would be given is if it's a 2 independent samples. Notice that's the only time the degrees of freedom are given. These ones up here, they're not given, and you have to do yourself. And it will require a subtraction. Okay, so what can you conclude about the null and alternative hypotheses? Well, the p-value is equal to, converting that to a percentage, 46.8%, which, what was our significance level? 0.05 or 5%, is 46.8% less than 5%. No, that's not true, right? That's a no. So that means this is statistically significant or not statistically significant?
No.
Not. Good. So we're not statistically significant. Do we reject or do we not reject the null? Do not reject. Do not reject the null. And do we support or do we not support the alternative?
Not.
Not. Good. And do not support the alternative hypotheses. Okay, almost there, guys. Last part, part G. We can now write a conclusion in the context of the problem. So, at the 5% significance level, the sample data support or do not support? Do not. Good. The sample data do not support the claim. And again, look back up here if you need to refresh your memory what the claim even was. The claim was, or what we're testing is whether the population mean response time is less than 60 days, right? That's what we were testing. So we do not support the claim that the mean amount of time to complete a financial aid application is less than 60 days. Phew. Gone through a lot. We're now done with 3 of the 6 questions. We've seen 3 different types of questions that may appear. Any questions on any part of number 3?
Could you zoom in on the bottom a little?
Yes. Oops.
Yeah, that's good, thank you.
So anytime we did a TCDF formula, we always use the degrees of freedom for n.
Correct. And then there's here's a friendly reminder for gosh dang it. There we go. For TCDF, you're going to do the lower value, the upper value, and then degrees of freedom. Are you guys ready for number 4? Okay, let's start number 4. An English instructor suggests that working in groups will improve your exam score by around 5 points. A random sample of 5 students took exams, first before and then after forming study groups. Construct a 90% confidence interval to see if the instructor's statement has validity. All right, before we go any further, we need to analyze what type of problem we're working with on our flowchart here. So tell me, was that 1 sample, 2 paired samples, or 2 independent samples? 2 paired. 2 paired. Because it's the same student. We're just testing before they did a study group, but then after they did a study group. Same student, before, then after the study group. Same student, before and after the study group. So they're paired because these pre and posts are linked to the same student. That's why they're paired. We're not just doing a pre and post of like random people, okay? We're linking them back to the same student. That's why they are paired, okay? So paired samples here. And then is this a confidence interval question or a hypothesis test? Confidence interval. So this is for number 4, doing the confidence interval for paired samples. Okay, and it says here, construct a 90% confidence interval. Okay, so before we go any further, there are questions there. Okay, part 8. Calculate the difference for each student in the table. Please take note. On the exam as well, we want to make sure you guys are very clear as to the order we want to see this. So be sure to read this so you know the order. Notice it's not pre minus post. That's usually the way we would do it. Okay, the majority of the time you just go in order, pre minus post, whatever comes first minus whatever comes second. But notice the order is reversed here. So just please take an extra second to make sure you do it in the correct order. Okay, so we're doing post minus pre in this example. So we're doing 85 minus 70. You guys see that? 85 minus 70, which is what? 15. Next, 45 minus 50 is negative 5.
Wait a minute. Why are we doing it that way?
Just because it explicitly tells us to. It's explicitly saying to do post minus pre. But otherwise, unless it says like otherwise, just go with the normal order. And I will have on the exam the order I want it in just to be extra safe. So just take note of the order that's given.
And just in my column, I would just assign it L2 minus L1.
Exactly.
Got it.
Did you have a question?
You answered that.
Okay. 87 minus 80 is 7. 95 minus 82.
13.
That's 13?
Is it?
Yeah.
Is it really?
Yeah.
Oh my god.
Weird.
That looks weird to me. 84 minus 74?
10.
Okay. So any questions so far? Okay. And again, just typically, normally, we do the first row minus the second row, but just be extra cautious in case we say otherwise, and we will be explicit about it, such as here. In this case, we said post minus pre, so it's this row minus the top row. Okay, part B, what is the sample statistics for the differences in exam points? So, sample statistics, we know that's our mean, the standard deviation, and then our sample size, right? Sample size is the easy part. Let's do that first. What's our sample size here? 5. Good. And then how do I find the mean and the standard deviation? In the calculator, right? Yeah. So stat, edit. I need to clear out this old stuff. So I'm only going to be entering in this bottommost row. I know some of you guys are now very comfortable with entering this in L1, this one in L2, and then calculate L3. If you want to do that still, by all means, go for it. But I'm not going to retype all this in. I just personally just only want to type in what I need here. Okay. So I'm going to do 15, negative 5, 7, 13, and 10. All right. And then stat. Calc, one variable stats, my first list. And here is my info. So my mean, you should have gotten to be 8, exactly. With a standard deviation, let's go to 3 decimal places, 7.874. Any questions? No, you guys are feeling good? Feeling good about this so far? Okay. All right, next, degrees of freedom. So we know to calculate degrees of freedom, that is n minus 1. And again, we know we're here. If you need a reference, go here for degrees of freedom, n minus 1. We said n was 5. So that'll be 5 minus 1, which is 4. Next, the critical value. That's our T sub c. And we know the only way to get the critical value is from our table, from our chart. So what do we have? We know that degrees of freedom is 4, and we know the confidence level is 90, right? So degrees of freedom, let's go to our table here. Here's the degrees of freedom. Here's the confidence level. Degrees of freedom we said is 4. Was that a student? Maybe. Okay. So degrees of freedom we said was 4. And the confidence level we said was 90, right? So where do those two values intersect?
2.132.
Yep, right here. 2.132. Degrees of freedom is 4. Confidence level is 90. They intersect here at 2.132. So 2.132. Okay, part E, find the margin of error. Again, if you don't recall, just go back to your formula sheet. Margin of error is this guy. That's our E equals. That is our margin of error. So E equals the critical value times the standard deviation over the square root of n. We have all pieces of information here, so plug it in. The critical value we said was 2.132 times S we said was 7.874 divided by the square root of n, where n is 5. All right, this is calculator. 2.132 times.
Today
Oh,
we're in
there's
the
another
kitchen
ad.
trying country crock plant butter with one.
There we go. Times 7.874 over the square root of 5. Let's go to 3 decimal places. I had gotten 7.508. Any questions there? Okay. Next, what is the confidence interval? Again, that's provided here. This is the confidence interval. X bar minus E, X bar plus E within parentheses. That's our confidence interval. So X bar minus E, X bar plus E. Where we know what the mean and what E are, we know both of them, so substitute them in. That'll be 8, X bar was 8, minus 7.508, comma, 8 plus 7.508. All right, so 8 minus 7.508. That'll be 0.492. 0.492, comma, 8 plus 7.508 is 15.508. I'm running out of space there. Lastly, interpret the confidence interval. So we are 90% confident that the mean difference in students' exams, working in groups, versus those that don't, is between 0.5, I'm rounding here, I should emphasize that, I'm going to be rounding these guys to 1 decimal place, is between 0.5 to 15.5 points. So, I mean, that's pretty good. Basically, what this teacher has found is that by working in groups, we're 90% confident that you're going to score better on the exams. And by how much are you going to score better? We predict you're going to score better somewhere between 0.5 and 15.5 points within that range.
After groups, it says versus.
Yeah, that's versus.
I have a question about interpreting the confidence interval
Mm-hmm.
In the context of the problem. So like when we're doing it at a significance level, we normally take like the claim and do it verbatim.
Mm-hmm.
So when we're interpreting a confidence interval, like what made you, is it because it's asking us to calculate the differences that you chose to write difference?
Yes.
Okay.
Yes, exactly. Since we specifically for this problem calculated the differences and worked with that data,
Got it.
right? Because after that, we were like, screw all this info. I want this
Just the
info.
differences.
That's what the focus was on. So since we're focusing on the differences, that's why I said main difference
Okay.
here.
Just because when writing it, what I took was the suggestion of improving your exam score versus the difference.
Yeah.
But since we're working with the difference, I should just use that.
Yeah.
Got it.
Any other questions here? So this one was a confidence interval for 2 paired samples. Any other questions? How are you guys feeling? You guys okay to just keep going? Keep chugging through this? We got 2 more. Maybe take a little stretch just for a second. Oh, I heard those cracks. Okay. Number 5. Excuse me. Okay, number 5. A Statway student claims that solely attending the tutorials and not doing the online Realize It homework will improve your exam scores. A random sample of 5 students who did not complete their online homework took math exams, first before and then after attending the tutorials. Test the claim using a level significance of 10%. Assume normality. Hint, use pre minus post. Okay, so it's giving us the order again. So before we do anything though, tell me, are we doing 1 sample, 2 paired samples, or 2 independent samples? Paired. Good. We're doing 2 paired samples because again, we're doing pre and post compared to the same student, right? We're analyzing the same student pre and then post. So it is paired. Is this a confidence interval or hypothesis test? Hypothesis test. Good. So this is for number 5. We're using this info down here, this test statistic, and we can use this info for degrees of freedom, etc. Okay, so part A. What are the null and alternative hypotheses? So let's start with that. The null is that mu equals what? 0, right? Because starting off neutral, we want to say that before and after doing the tutorials, there's not going to be any difference. Okay, just starting neutral. Anytime you're doing the hypothesis testing for paired samples, you can assume you're starting off with mu equals 0. Okay, that it's neutral. No difference between them. Now, what about for the alternative? Is mu going to now be less than 0, mu is greater than 0, or mu simply does not equal 0?
Greater?
Mu is greater than 0, and we can say that because, test the claim. Oh wait, where'd the claim go? The student claims that by doing tutorials and not doing their homework, it will improve your exam scores. So that means comparing pre to post doing the tutorials, your exam scores will go higher. So mu is greater than 0.
I just had a question. If it doesn't specifically say pre minus post or post minus pre, would we just put that in order of what comes first?
Exactly. Yeah, if it doesn't specify the order to follow, then just do it in the order as you see it. Yeah. This part I'm going to do over here, you don't need to write. I'm just writing this as extra in case it's a helpful visual for anyone. In case you're struggling recognizing what to do with these, what to set mu equal to, and then for the null and alternative, then just write it out. Okay, doing pre minus post. Okay, pre minus post. So for pre minus post, and then you can even do an example in your own head, right? So the student claims that it will improve your exam scores by attending the tutorial, right? So before pre-tutorial, You can think of it that way. Pre-tutorial, your exam score will be lower, correct? Post-tutorial, you expect your exam score to then be higher. Do you guys agree?
Yes.
So it's lower minus higher. Anytime you have a lower number minus a higher number, is that positive or negative?
Negative.
That's negative. That's a negative result, which is why we then said that mu is, wait, did I do this wrong?
I don't think the
Pre-
problem's right.
Say again.
It should have been post minus pre, right?
Post minus pre. You know what? No, I just did my answer key wrong. That's all. So yeah, this is actually very good we did this. Because of the order, it's gonna be less than 0. Because of this
Oh, that's
order.
why I thought post minus pre, because.
Exactly. I think we were both under this thought still. Post minus pre.
And then,
We were still thinking on the
And
last
doing
example,
post
but then they
minus pre.
swapped it. So yeah, actually, that's why another reason why I highly recommend, regardless if you think you're on the right track, still do something like this off to the side so you can check your work. Okay, so I just wrote pre minus post here because that's what it's telling me to do. It's telling me to do pre minus post, and then I plugged in essentially what the values would be. Pre-tutorial, right? Pre-tutorial, the exam score would be lower. Post-tutorial, after you've done the tutorial, the exam scores would be higher. So anytime you have a lower number minus a higher number, you expect that result to be negative, which is why we're saying mu is less than 0. This was actually a great example to put this to the test.
Yeah, I wouldn't have.
So any questions just on this part here before we move on?
Wouldn't like all the differences have to be negative in order to put that factor into play?
No. If this had said post minus pre, it would have been greater than 0.
Yeah.
So the order really matters here.
So it will always be 0, but the only thing that would change would be greater than or less than.
Exactly. The null, we can always start off with assuming mu equals 0. That there's no difference between the pre and the post, so that way when you subtract them, you get 0. They're exactly the same. There's no difference between them. And then to determine this one, the alternative, personally, I think it's extremely helpful to write it out. Write out the order, pre minus post, and then think through it what that means. Pre-tutorial, they get lower exam scores. Post-tutorial, it would be higher exam scores. So specifically in this order, a lower number minus a higher number would result in a negative. Since it's negative, mu is less than 0. Okay? Yeah, and if this had been swapped, if it had been post minus pre, then we would have ended up with a positive result, meaning greater. Okay? So excellent questions here, guys. Any other questions here? Okay. Part B, calculate the differences for each student. And again, be careful with the order. We're doing pre minus post. So pre is the first row minus post the second row. So 75 minus 85, 50 minus 45, and so on. All right, so 75 minus 85 is negative 10. 50 minus 45 is 5. 80 minus 85 is negative 5. 85 minus 95 is negative 10. 95 minus 95 is 0. Okay. Any questions there? Again, the order matters. It said pre minus post, so I did top row minus bottom row. In the previous example, it was post minus pre, so we did this row minus the top row. The order matters. Part C, list the sample statistics. So we know that's the mean, the standard deviation, and n. Let's start off with the n. Oh, question?
Okay, I just had a question. If mu isn't given, will it always be 0? Or like, could we always assume it's 0?
No. Because, for example, it might just say something like the majority of. Majority means 50%. Right? So it doesn't explicitly say it, but then you got to be able to interpret it.
Say anything like that.
We haven't done anything like that, but in previous chapters we were. Yeah. But here we've been luckily a bit more explicit so far. So what's n? What's our sample size?
5.
5. Good. All right, to get the mean and the standard deviation, gotta use our calculator. So stat, edit. I'm gonna delete all this old stuff. Oops. Okay, and again, some of you may be comfortable entering this into L1, this into L2, making this your L3, but these numbers, there weren't that many numbers here, so I actually think it's easier just to do the bottom row, you know. But again, it's a personal preference. So I'm just gonna be entering in the bottom row. -10, 5, -5, -10, and 0. Stat, calc, 1var stats, and we get the following. Well, actually, I got something different. Did I do this wrong? Oh, I missed my last one. -10, 5, -5, -10, 0. I missed the 0. There we go. Okay. Stat, calc, 1var stats. Another add. There we go. Enter, and here it is. Okay. So you should have gotten your mean to be -4. The standard deviation S, I got 6.519. You guys agree?
Mm-hmm.
Okay, cool. So any questions there?
Nope.
All right, calculate the test statistic, which again, go back to here if you need to. We had said that we were working with a paired sample hypothesis test. This is where we are for number 5. So here's how we calculate the test statistic. So I'm going to bring that over. So T equals X bar minus mu over S over square root of N. We have all of this information, so substitute it in. The mean was -4 minus mu is 0 over S, which is 6.519, divided by the square root of N, which is the square root of 5. I'm going to plug this into my calculator. So we have -4. You could just leave it as -4. -4 minus 0 is -4. But if you want to do that, -4 minus 0, that's fine as well. Up to you. In the denominator, we have another fraction. 6.519 over the square root of 5. So you should get, let's go 3 decimals, -1.372. Which matches, we got a negative result here, which matches the left-tailed test as expected.
Is this where I have to do it separate?
Yeah, if you need to do it in several steps, that's okay. Any questions there? All right, so p-value. P-value equals TCDF. It just was coincidence that these were all left-tailed tests. So lower bound, upper bound, the degrees of freedom. What's the degrees of freedom here?
4.
4, good, because you do 5 minus 1, which is 4. N minus 1, 5 minus 1, which is 4. All right, so distribution, TCDF. Lower bound is -infinity or just -99999. Upper bound was -1.372, comma, degrees of freedom is 4. Should get 0.121. Part F, or any questions there? Part F, what can you conclude about the null and alternative hypotheses? Well, the p-value is equal to, converting that to a percent, that's 12.1%. What was our significance level? 10, significance level 10%. Is 12.1% less than or equal to the significance level of 10%? No, it's not, all right? 12.1 is not less than 10%. Therefore, are we statistically significant? No, not statistically significant. Tell me, what do we do with the null and the alternative?
We do not reject the null.
Do not reject the null. And what?
Do not support the alt.
And do not support alternative. Good. Lastly, we can write an overall conclusion. So at the 10% significance level, the sample data do not support the claim that for students who do not do their homework and only attend tutorials, their exam scores will improve. And I think I changed the wording there a little bit, but that's okay, right? It doesn't have to be exactly, just so long as you get the same point across. Yes,
It's okay if I just say sample data does not, or no, should I write the way you wrote it?
does not what?
Like when you're at the 10% significance level of sample data, can I write does not?
But you have to continue. You have to put it in the context of the problem.
No, I know, I'll write the rest, but I'm saying instead of do not.
Oh yeah, my English is not.
Oh.
That's probably not.
Yeah.
That's probably not grammatically correct, but. Any other questions? I still see some people writing. Are you guys already working on the next one, or are you finishing? Okay, no. Okay, we'll wait another minute here. Anyone need more time here? All right, guys, we're almost there. Last question. Drum roll. Okay, number 6. A random sample taken by the Bureau of Economics Analysis shows a comparison between mean income for Lakewood and Long Beach residents. Of 36 Lakewood residents, the mean income was $31,987 with a standard deviation of 5,000. Out of 49 Long Beach residents, the mean income was $33,179 with a standard deviation of 6,000. Construct and interpret a 95% confidence interval for the population mean. The degrees of freedom is 79. All right, guys, so first things first, where am I going? Is this one sample, 2 paired samples, or 2 independent samples? 2 independent samples. Good. Is this question asking for a confidence interval or hypothesis test? Confidence interval. So we will be using this guy here. So for question 6, we're using this here. Here's our margin of error formula. Here's our confidence interval. And here's information about degrees of freedom, etc. Okay, so this is what we're using here. Part A. List out and organize the sample statistics. So tell me, am I going to have just one set of sample statistiks or two? Two, because we're working with independent samples. Good. So for group 1, I'm just going to go in order. So I'm going to say that was Lakewood. So we're going to find the mean sub 1, standard deviation sub 1, and n sub 1. Okay, so let me find all of Lakewood info. Let's see, 36 Lakewood residents, mean income 31,987, standard deviation 5,000. So I'm just taking that info and organizing it. So there was 36 residences. The mean was 31,987. Standard deviation was 5,000. For the second group, group 2, that was Long Beach. And similarly, we need to find its mean, its standard deviation, and its sample size. It's also given within the problem. There are 49 residents for Long Beach. The mean was 33,179, standard deviation 6,000. Okay, so 49 residences. The mean was 33,179, and standard deviation 6,000. Any questions there? Okay. Find the difference in sample means. So remind me, what does difference mean?
Subtraction.
To subtract, and we're subtracting the sample means. What are the means? These guys, right? The difference in the sample means. So we're just subtracting these two values that we found. So x1 bar minus x2 bar, that'll be 31,987 minus 33,179. So 31,987 minus 33,179. I got negative 1192. Okay.
So it always has to go in that order, right? When you subtract it?
Yes. Yeah, always x1 minus x2.
Can I write that on my formula sheet?
If I recall correctly, that's actually given on the exam.
Okay.
Yeah. Part C, find the critical value. Now remember, typically for the critical value, we would be using this table, correct? But this table only goes up to a degree of freedom of 20, whereas our degrees of freedom here is 79. This is an instance where it would require a new tool such as Desmos, okay? Will a question on the exam appear in which you can't find the critical value because it requires Desmos?
No.
No. All right. So this would require this. So I'm just going to search for it. Well, let me type it in. There we go. So Desmos T critical value. Let's see if it pops up on here quickly because I'm... Oh, yeah, here it is. No, that's not it. Here it is. T critical values. Desmos down here. That's the one you want. It's loading. It's thinking. Just very slowly. I only have 2 bars. Oh, there it goes. It's starting to load. Okay, here we go. All right, so degrees of freedom. So what we need are the degrees of freedom, and we need the confidence level, which I forget what both those are. So degrees of freedom was 79, and was the confidence level?
95.
95, right here. So 79 and 95. So that's what we're using. So degrees of freedom is 79. Oh, and the confidence level is already 95. You guys see that? Mm-hmm. So then the critical value is given here, the T sub C. So it is 1.99. Okay. So the critical value is 1.99. Again, on the exam, the degrees of freedom, oops. The degrees of freedom And the confidence level will be something to where it fits within the chart. Okay. All right, next, find the margin of error. All right, well, let me go back here. Confidence level, 2 independent samples, confidence interval, margin of error. The formula is given here. It's the E equals, right? That's the margin of error, the E equals, which is T sub C times the square root of all of that stuff. So I'm going to bring that on over. So margin of error equals T sub C times the square root of S1 squared divided by N1 plus S2 squared divided by N2. All right, and that was just from this formula. We have all that info, so go ahead and plug it in. So that is 1.99 times the square root of 5,000 squared divided by 36 plus 6,000 squared divided by 49. Now, again, depending on how comfortable you are with this, some of you might want to do this all in one go. I'm actually going to break it down into 2 steps. So I'm going to just bring the 1.99 over. So 1.99 times, and then I'm going to, in my calculator, first figure out what that square root is. So the square root of, another add. Let's get out of it. There we go. So square root of 5,000 squared over 36 plus 6,000 squared over 49. You get 1,195.466. I rounded that to 3 decimal places.
That's not what I got.
Oh, you guys got some, did I do something wrong?
No, I more likely we did.
Did anyone else get what I got?
No, I got 2389.736.
Everyone got something different? Did I do it wrong? Square root of 5,000 squared over 36 plus 6,000 squared over 49. Let me come around to you guys.
No, I mean, I got that, my answer.
Oh, so let me also go
She
ahead.
hasn't done the whole.
Oh, okay, let me go ahead. Yeah, some of you guys might be ahead of me actually. So let me go ahead and finish real quick. So 1.99 times 1,195.466. So my final answer is 2,378.977.
Was it multiplied for some reason?
Give me a moment.
Yeah, you got that?
1195.
Okay, cool.
0.466.
And even though these are really big numbers, don't let that freak you out because we're talking about income, right? We're talking about residents' income, and their income was in like the tens of thousands of dollars. So
For me, I think the big thing is gonna be figuring out, because my calculator is different.
yeah,
It's figuring out.
practicing how to best do it. Some of you may have done it all in one go. Let me show you what that would look like.
If I shortened it
1.99.
to 2 decimals after, because it's in money, does that matter?
Just whatever the problem says to round to. That's what you want to go to.
Well, sometimes they don't.
Yeah, right. Well, on the exam, just ask me. Yeah.
Okay.
If there's any concern. So 5,000 squared divided by 36 plus 6,000 squared divided by 49. So if you do it all in one go, you should end up with the same answer after you've rounded it. So it just depends, whatever your comfort level is. Did you do it all in one go or separate?
Yeah, I did.
Oh, you put an extra 9 there. It's only 2 9s.
Oh, I remember.
Okay. Any other questions here before we move on to part E? Okay, part E, find the confidence interval, which again, go to here if you need to. The confidence interval is, notice it's a little bit different. It's x1 bar minus x2 bar minus E comma, x1 bar minus x2 bar plus e, which we've already found a portion of that. So x1 bar minus x2 bar minus e, comma, x1 bar minus x2 bar plus e. We already found the x1 minus x2 portion, right? You guys agree? We already found this. We did that here, x1 minus x2 bar. We already did that. So I'm just going to take, instead of substituting all those numbers, I'm just going to take that result, the negative 1192. So that's negative 1192 minus E, which we said was 2378.977, comma, negative 1192 plus 2378.977. And that equals, I'm running out of space here. I'm actually going to bring it back up here. So the final answer is negative 1192 minus 2378.977. So that'll be negative 3,570.977, comma, negative 1192 plus 2378.977. And that'll be positive 1,186.977. So that's the confidence interval. I know, it's ugly decimals. And you know what? It didn't even like fully give us. Oh yeah, okay, never mind. All right, so part F, interpret the confidence interval in the context of the problem. What was our confidence level again? 95, thank you. So, we are 95% confident. We are 95% confident that the population difference, or if you want to, you can also say the mean, right? The mean difference, because that's what we were doing here, right? We were subtracting them, right? Overall, we're subtracting them. So we're 95% confident that the mean difference
In income
is between negative $3,570.98 and positive $1,186.98. So what is that telling us? Is that telling us that Lakewood, that we are 90% confident that the average of the Lakewood income is for sure going to be more than Long Beach?
No, it's just saying the difference.
It's just saying they're different, right? Because look here, where am I? Some is negative, some is positive, right? So sometimes Lakewood is higher, sometimes Long Beach is higher. It goes back and forth. If it was all positive, if we didn't have this negative here, if it was all positive, then that means Lakewood is always greater than Long Beach.
Right.
If it was all negative, right? If it was all negative, then that means Long Beach is always greater than Lakewood, right? But when you have a mix like this, then we're like, it goes both ways, right? Lakewood could be more or Long Beach could be more. You guys, we did it! Yay! So remember, on the exam, there's going to be 3.
No tears.
Yeah, no tears. There's going to be 3 free response questions that are coming from like the 6 we did. Right? There's 6 different types we did. 1 sample, confidence interval hypothesis test. Paired samples, confidence interval hypothesis test. 2 independent samples, confidence interval hypothesis test. So 3 of the questions will be similar to the 6 we did here.
What about the rest of them?
And the multiple choice is just, overall understanding, conceptual knowledge. All right, guys, I'm going to stop recording.